Interesting for people. First of all, we are born scientists. When we're born, we wonder what's out there. We begin to wonder about the sun, life, the stars, what makes the oceans, the weather. We're born scientists. And then something happens.
You may not have heard about Michio Kaku, but he's an American theoretical physicist who recently released Soviet's Venus photos. Hold on, space fans. These never-before-seen images are incredible, and these old photos are going to reveal Venus's secrets. What could Soviet images reveal about this mysterious planet? Are we about to rethink the universe? Join renowned physicist Michio Kaku in discovering long-hidden mysteries among the stars. Before we dive into the specifics, history is needed to understand the significance of these declassified Venus documents. From 1945 to the 1980s, the Cold War spurred cosmic exploration. The US and USSR competed in military, politics, technology, and science. This rivalry saw space technology breakthroughs. The space race wasn't just about conquering space. It was a symbol of these superpowers' technological prowess. The Soviet Union wanted to show its capabilities in this area. The 1957 launch of Sputnik, the first artificial satellite, was a turning point. Space exploration began with this historic event. Sputnik's beeping signal signaled the start of a race to the stars and international fame. Why did Venus dominate this time? Venus, our nearest planet, is Earth's sister planet due to its size and composition. Like all siblings, there were significant differences. How similar Venus was to Earth intrigued scientists and the public. Could it be humanity's second space home? The Soviet Union wanted to answer these questions. Venera missions began, and the Soviet Venera spacecraft explored Venus. These missions sought to understand Venus's atmosphere, surface, and conditions. The Soviet Union's Venera probes captured the first images of another planet, according to Michio Kaku's book. Of course, Venus exploration was difficult. Temperatures could melt lead, sulfuric acid clouds covered the sky, and atmospheric pressure could flatten a person. The Soviets faced the unknown head-on despite these daunting challenges. In 1961, Venera 1 began. It missed Venus by 62,000 miles. The Soviet Union rebounded and launched Venera 2 the following year. Like its predecessor, Venera 2 too missed Venus. We must understand the space race and the Soviet Union's relentless exploration of Venus to fully appreciate the declassified photos. These stunning images from the past will change our view of Venus and the universe. The Soviet Union launched Venera 3 in 1965, believing third time's a charm. Gold struck this time. Venera 3 crash-landed but transmitted data to Earth for a few minutes before succumbing to Venus's harsh conditions. This changed the Soviet space missions. Now, the Soviet Union redesigned their spacecraft to be more robust after realizing Venus's data was needed. Each spacecraft had a descent module with cutting-edge tools. These modules had barometers, radar altimeters, gas analyzers, and thermometers. Within Venus's short survival window, data collection was the goal. Let's return to our intriguing question. We may need more historical data, Venera mission records, and declassified Soviet space program documents to discover what the Soviets discovered on Venus and kept hidden. Venera continued even after Venera 3. Venera 4, a Soviet mission, changed the game. After landing on Venus, Venera 4 made important discoveries. Venera 4 discovered Venus's atmosphere was rich in carbon dioxide. Why is this important? CO2 traps heat. Venus's surface temperature is 864 degrees Fahrenheit, hotter than Mercury, the closest planet to the Sun, due to its high carbon dioxide content. This discovery illuminated Venus's climate and geology. Given the similarities between Earth and Venus, it provided a glimpse into a possible future if greenhouse gases continued to accumulate. Venus, in a way, warned Earth of the dire consequences of greenhouse gas accumulation. Revelations continued. Venera 4 showed that Venus has no global magnetic field and a carbon dioxide-rich atmosphere. Our magnetic field shields us from solar winds and radiation, allowing life. The lack thereof on Venus suggested it may not support life as we know it. This discovery illuminated planetary magnetic field formation and evolution, helping us understand the habitability of other planets in our solar system and beyond. After 90 minutes, Venera 4's mission ended. The probe disappeared into Venus's dense atmosphere due to its harsh conditions, rendering it inoperable. The 90 minutes were well spent. Data from this mysterious planet revealed its secrets one by one. In 1969, Venera 5 and 6 were launched towards Venus after Venera 4's success. These spacecraft were stronger and had more precise atmospheric data-gathering instruments. It's interesting to see that despite the lack of visible discoveries, the Soviets remained determined on their Venera missions. 5 days later, Venera 6 was launched. It measured atmospheric pressure, chemical composition, density, oxygen-hydrogen distribution, cosmic particle streams, and temperature. On May 17, 1969, Venera 6 sent Earth 51 minutes of data during its descent. Despite photometer failure, it provided Venusian atmosphere data at 2 and 10 bars. Venera 5 and 6 needed smaller parachutes because of Venus's dense atmosphere. The capsules reached their desired depth before powering down. These missions confirmed Venera 4's high temperatures, pressures, and carbon dioxide levels on Venus. Venus became unlivable. Venera 7 and 8 also excelled. These Venus probes transmitted vital data to Earth. Venera 7, the first soft landing and data-transmitting spacecraft, was launched in August 1970. To survive Venus's harsh conditions, the probe measured temperature, pressure, atmospheric density, accelerometer, and radar altimeter. Missions continued despite failure. The tapes showed weak 23-minute signals weeks later. When Venera 7 landed on Venus, it flipped over, misaligning the antenna. The probe recorded 20 minutes of data at 887 degrees Fahrenheit and 1,300 psi. In 1972, Venera 8 had a smoother landing. It had temperature, pressure, light, altimeter, gamma-ray, gas, and radio transmitters. Pre-chilling Venera 8's descent capsule before atmospheric entry extended its surface life. Aerobraking slowed its descent to 900 kilometers per hour, and the parachute opened at 60 kilometers. Venera 8 reported wind speeds of less than 1 meter per second below 10 kilometers and decreased illumination at 35 to 30 kilometers altitude. Clearly, Venera 7 and 8 helped advance Venus exploration. The Soviets analyzed their failures, including Venera 7's poor landing, and improved their future missions. Venera 8's data revealed that Venus's atmospheric pressure was 90 times Earth's at sea level. Venera 8 sensors worked well under this pressure. The probe also recorded ambient light levels on Venus, suggesting that cameras could be used to capture visual data. The Soviets wanted to see Venus's surface, setting the stage for Venera 9 to 12. Each mission revealed new Venusian mysteries. Many cameras on these probes failed due to harsh conditions. A few managed to take the first photos of our solar system's second planet. The Venera probes found no water, oceans, or life on Venus. However, their findings illuminated alien planets' extreme environments, revealing how different they are from Earth. The probes revealed fascinating findings despite the lack of life. Venera 13 captured Venus's eerie winds. This was the first time sound was captured on a planet other than Earth, making it a memorable moment in space exploration. Venera 13, originally designed to work for 45 minutes on Venus's hostile surface, outlasted itself by 127 minutes. It sent back stunning color photos of the planet during its extended operational period, revealing a barren and desolate landscape unlike anything we had seen before. Similar surprises continued. Venera 13 also sampled Venusian regolith. Humans had never analyzed another planet's soil before. This exploration revealed that Venus has titanium and iron. We gained such deep insights about a planet over 100 million kilometers away in the 1980s, which is amazing. Venus has infernal temperatures and an atmosphere nearly 100 times denser than Earth's. Venus's backward rotation and lack of oceans or bodies of water make it a frightening place. Venus exploration continues despite these hostile conditions. Roscosmos is developing Venera D, a 2029 Venus mission. This ambitious mission with an orbiter and lander will set the standard for Venus missions. In early autumn 2020, MIT scientists made a shocking announcement. Venus's atmosphere contained phosphine. This was significant because phosphine gas may indicate life. This claim may be supported by NASA's mission data from over 40 years ago, adding to the intrigue. In December 1978, 4 probes were launched into Venus's atmosphere. one of which was larger and carried the Large Probe Neutral Mass Spectrometer, LNMS. The LNMS used detector collisions to identify atmospheric molecules. This device measured Venus's known atmospheric molecules, such as carbon dioxide, sulfur dioxide, and argon. The LNMS may have detected other molecules, such as phosphine. The Pioneer Venus mission's re-examination and the discovery of phosphine in Venus's atmosphere have excited and intrigued scientists. Venus could have life if it has phosphine. However, more data is needed to confirm and understand phosphine's origin. The presence of phosphine, a biogenic gas on Venus, has raised questions about its habitability. It's important to note that Venus's conditions are very hostile to life. Venus has a thick carbon dioxide atmosphere, high surface temperatures that melt lead, and crushing atmospheric pressure. It's safe to say that Venus and phosphine research have raised exciting possibilities for life beyond Earth.
A stellar showstopper in the night sky. Betelgeuse stands out as an extraordinary celestial phenomenon on the verge of becoming a supernova. What makes it distinctive? Well, it's an immense star, surpassing our Sun by 700 times in size and being approximately 15 times more massive. This supergiant, as it's well known, behaves as a cosmic mystery. Researchers are consistently fascinated by its irregular dimming, which happens about every 430 days. Every 6 years, like clockwork, large dark spots show up on its surface, similar to the sunspots we observe on our Sun, but on a much larger scale. This has caused concern among scientists, particularly prominent experts such as physicist Brian Cox. Cox cautions that Betelgeuse could undergo a supernova eruption soon, potentially impacting Earth in significant ways. This giant underwent a particularly dim phase in February 2021, shining a bit less brightly than usual. Despite its immense size, Betelgeuse emits less energy per unit of surface area compared to our Sun, because it runs cooler at around 3,500 Kelvin, while our Sun sits at a toasty 5,500 Kelvin. That's why it sometimes seems dimmer than expected. Betelgeuse has been stealing the spotlight in our night skies for ages. Even Greek astronomer Ptolemy took note of its reddish hue. Back then, they only had color and position in the sky to describe stars. But thanks to modern astronomy armed with advanced techs like the James Webb Space Telescope and the Hubble Space Telescope, we've unraveled a lot more about this celestial giant. The Hubble Space Telescope's detailed images revealed patterns of gases and dust clouds on Betelgeuse's surface, while the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory caught a light wave coming from the Orion constellation, where Betelgeuse sits on the left shoulder of Orion. But there's more. ALMA, an observatory in Chile, provided ultra-high-resolution images of Betelgeuse's surface, giving us a closer look at its behavior. Scientists discovered an expansive gas plume extending from the star's surface, likely a result of Betelgeuse's pulsations caused by the cyclical movement of hot and cool gases within the star. These pulsations create star spots, areas with intense magnetic activities and cooler temperatures compared to the rest of the star's surface. These spots, believed to be much larger than Earth, directly influence Betelgeuse's brightness. The more star spots, the dimmer the star appears, making it a fascinating puzzle for astronomers to decipher. Now this is where it starts to get intriguing. The countdown to Betelgeuse's supernova. The recent gravitational wave readings from Betelgeuse have stirred quite a buzz among astronomers. You see, the dimming we've been observing is a bit of a telltale sign in the cosmic drama of a star approaching the grand finale of its existence. But here's the twist. Stars, like Betelgeuse, with their magnitude and brilliance, don't gracefully fade away. No, they prefer to go out with a supernova explosion, befitting their cosmic stature. Now, scientists are contemplating the possibility of Betelgeuse putting on this spectacular celestial show. If it happens, it would be like hitting the cosmic jackpot, offering us invaluable insights into the mysteries of the universe. Imagine witnessing a red supergiant bidding farewell in a fiery blaze observable even in the daylight. Intriguing, right? Recent data from the James Webb Space Telescope and the Hubble Space Telescope hint at some fireworks a few years ago when Betelgeuse underwent a significant eruption, losing a chunk of its visible surface. This triggered a massive surface mass ejection, basically a cosmic sneeze that raised eyebrows among scientists. It's not your typical star behavior, especially for one of Betelgeuse's stature. Despite ongoing scrutiny, the star seems to be on the road to recovery from this substantial ejection. But the recent phenomena surrounding Betelgeuse remain a cosmic head-scratcher for scientists. It's like the universe is teasing us with its celestial puzzles, and Betelgeuse is at the center of it all. Observations from the James Webb Space Telescope provide a fascinating peek into how red stars shed mass as they approach the end of their cosmic journey. Betelgeuse, in particular, seems to be shedding mass at an unprecedented rate. The recent significant loss of mass raises some serious questions about the fate of this colossal red star. Scientists are on high alert, working diligently to unlock the mysteries of these occurrences. The massive ejection of mass from Betelgeuse is thought to have originated from a convective plume spanning over 1 million miles across its surface. This plume, like a cosmic fountain, generated powerful pulses and shocks, leading to the expulsion of a chunk of the star's outer layers. The result? An expansive surface beneath a dust cloud, a cosmic aftermath visible from our little blue planet. Betelgeuse, now grappling with the fallout of this upheaval, experienced a significant dimming in 2019. The lost mass, weighing several times more than our moon, dispersed into space, forming a dust cloud that played hide-and-seek with the star's brilliance for several months. Even amateur astronomers, armed with just their passion for the cosmos, noticed this cosmic spectacle. The universe sure knows how to put on a show. Clues, controversies, and the supernova puzzle. For more than 2 centuries, scientists and astronomers have been closely studying Betelgeuse, noting its rhythms and movements. They've meticulously documented noticeable disruptions that underscore the profound impact of this stellar blowout. Recent analyses from the TRES and Hubble spectra indicate that while the outer layer may return to normal soon, the star's surface remains in a delicate state, awaiting the completion of the photosphere rebuilding process. In contrast to our Sun's coronal mass ejections, Betelgeuse's recent surface mass ejections highlight a stark difference in magnitude. Betelgeuse's expansive growth over millennia is evident, with its outer orbit potentially extending beyond Jupiter's. The red hue of Betelgeuse signifies that it has reached a stage where stellar bodies deplete their hydrogen reserves, leading to core collapse and the outer layers puffing out. Comparatively, our Sun is still relatively young, with an estimated 5 billion years before reaching a mature stage where its radius may expand to proportions reaching Mars's orbit. After the significant dimming of Betelgeuse in late 2019, scientists scrutinized its altered behavioral pattern. Despite regaining brilliance within months, the initial cause of dimming puzzled scientists. Various hypotheses were proposed, including star contraction before an impending explosion. However, data from NASA's James Webb Telescope dispelled this theory, attributing the dimming to dust clouds raised from ejections. Scientists now believe a supernova event is not expected for another 1.5 million years, placing Betelgeuse in its late evolutionary stage. According to Salvatore Vitali, a physics professor at MIT, the detected wave from Betelgeuse may not necessarily originate from the star itself. Vitali points out that, before a supernova, neutrinos are typically released, which hasn't happened in Betelgeuse's case. The fact that Betelgeuse still illuminates, albeit dimmer than usual, makes it an unlikely source for gravitational wave emission. Uncertainty surrounds whether the intercepted wave is indeed a gravitational wave, as it lacks characteristics of known mergers. The cause of the detected wave remains elusive, and the debate continues among researchers. The ongoing debate among researchers about Betelgeuse's potential supernova includes speculations about its imminent end or the possibility of tens of thousands of years left. The most recent supernova observed in our Milky Way galaxy was in 1604, with potential subsequent nearby supernovas hidden by atmospheric gas and dust. Instances like the Crab Nebula from a supernova in 1054 serve as remnants of explosive events. More recent observable occurrences include the 1987 supernova in the Large Magellanic Cloud and the Kepler supernova in galaxies beyond our Milky Way. Probing cosmic explosions through modern telescopes. Witnessing a star explosion in our galaxy is rare, with astronomers estimating an average of 1 to 3 supernovae every century. Modern telescopes, compared to those of Kepler's time, are better equipped to capture visible light and provide insights into how supernovae would appear if observed nearby. Infrared telescopes like the James Webb Space Telescope extend beyond visible light, penetrating gas and dust to reveal celestial objects not visible with conventional telescopes. The dynamic nature of the universe continues to unfold before our eyes. Apart from observing light, scientists employ specialized detectors to catch neutrinos and subatomic particles emitted by supernovae. These detectors, alongside instruments for gravitational waves, offer another dimension to studying these cosmic events. Supernovae fall into two main types. Type 1 involves a runaway nuclear reaction in a white dwarf star, while Type 2, known as core collapse supernovae, results from a star collapsing under gravity after running out of nuclear fuel. Type 2 supernovae are particularly fascinating as they emit not only light, but also a significant amount of neutrinos. Neutrino emissions might even precede the visible explosion, allowing detectors to pick up signals before the actual event occurs. Betelgeuse, experiencing recent brightness fluctuations, sparked speculation about a potential supernova explosion. However, recent research suggests that the dimming might be attributed to dust clouds or sunspot activity on the star's surface. Nonetheless, anticipation remains high among astronomers for the eventual explosion of this massive star. To enhance detection capabilities and provide an early warning system, astronomers have established the Supernova Early Warning System, SNOOS, a network of neutrino detectors across various countries, including Antarctica. SNOOS aims to automatically alert astronomers if galactic supernova neutrinos reach Earth, offering valuable data for studying the event. The upcoming SNOOS 2.0 seeks to improve triangulation capabilities. Advancements in neutrino science since the 1987 A supernova suggests the potential capture of thousands or even hundreds of thousands of neutrinos by a global detector network during a galactic supernova. If a collapsing star forms a black hole, the sudden stop of the neutrino stream could signal this phenomenon. Astronomers could identify potential black hole locations by observing blank spaces in lists of known stars. While massive stars undergo captivating supernova explosions, their proximity to Earth raises safety concerns due to potential dangers if an explosion occurs within a specific minimum safe distance. Evidence of a starburst around 3 million years ago near Earth has been discovered through the presence of radioactive iron atoms in lunar cores and deep ocean samples. These unique atoms are traces of supernova explosion remnants, enabling scientists to study the nuclear processes driving exploding stars and uncover events predating recorded human history. A nearby supernova, like one that occurred close to Earth, likely released significant radiation throughout Earth's history. Despite these cosmic challenges, life persists on our planet. Supernova explosions, though offering a spectacular view from a distance, pose hazards for onlookers nearby. Neighboring supernovae can impact Earth-like planets' biospheres through high-energy gamma rays, cosmic rays, and prolonged intense X-ray radiation, potentially harming terrestrial and marine life and affecting the ozone layer. These relatively infrequent yet potent events raise the galaxy's overall danger level, akin to the threat posed by more common explosions. Supernovas and Earth's vulnerable shield. Now let's talk cosmic fireworks, supernovas. These celestial explosions aren't just spectacular light shows. They've got some serious power. A single supernova can outshine our moon, and that's not even the most mind-blowing part. Recent research has uncovered some eye-opening findings. Turns out, certain supernovas don't just stop at putting on a dazzling display. They can potentially mess with a planet's ozone layer, exposing life to some seriously harmful radiation from our very own sun. Now, you might think, but they're so far away, how could they affect us? Well, buckle up. While the initial burst might blind us with visible light, the real danger lurks in the shadows, cosmic rays. These sneaky particles can wreak havoc on our ozone layer, leaving us vulnerable to the sun's unforgiving UV rays. Cue potential extinction event. But hold up, no need to panic just yet. Astronomers have been keeping an eye on the cosmic neighborhood, and thankfully, there aren't any supernovas poised to ruin our day anytime soon. Yet, there's this new kid on the cosmic block, a specific type of supernova that, when it happens near a bunch of cosmic material, could shoot out hazardous radiation in all directions. Picture this radiation bombarding a planet like ours, messing with its protective layer and setting the stage for a potential cosmic catastrophe. Think of it like a lethal combo punch. First, the X-rays hitting us like an interstellar laser show, then cosmic rays arriving fashionably late to finish what the X-rays started, leaving our biosphere in a bit of a fix. While the chances of a close supernova posing a direct threat are slim, there's evidence from when that suggests a supernova might have had a hand in a prehistoric extinction event. Fossils hint at a link between a supernova and some crispy plant spores from around 360 million years ago. So, while we're not in immediate danger of a cosmic apocalypse, it's fascinating to ponder the cosmic ballet happening light years away and its potential impact on our little blue planet. The James Webb Telescope recently found something that's absolutely mind-blowing. Sadly, it's not getting much attention yet. Scientists and space fans are buzzing about it. Guess what? They've just launched cool JWST special edition phone cases for the new year, and you can grab one right now. Click on your screen or check the first link in the description to see them for yourself. Do you believe that Betelgeuse's potential explosion will significantly impact Earth's night sky? Share your thoughts in the comments below.